Pete Zelinski. We're at Lifestyle Additive Manufacturing. This is Nate Stevens, Operations Director.
Hello.
Lifestyle is a specialist in selective laser sintering, additive manufacturing, 3D printing of polymer. 2 piles of nylon polymer, different as you can see in color. The darker material, the black material, Nate, is special. Can you tell me about this?
Yeah, so this is ALM's new HD 950 material. It's a nylon 12, but it has the carbon fully encapsulated in the nylon, which gives it that black color. And works just like the white nylon, but when it's done, it has that deep black finish that most people want out of their nylon, but need to use a dyeing process to get to.
So the black material, the inherent black as an alternative to dyeing, just the color alone would be valuable, but Lifestyle, in their experimentation with this material and developing the processing parameters for it, you've discovered other interesting properties.
Yeah, with the black, we've noticed an increase in precision. We've noticed an increase in dimensional stability. We've also noticed that there are some inherent anti-static properties as well.
The precision difference, we have another video where we talk about that a little bit more, show some different parts that pick up that difference in accuracy. But now we're going to do a demo that illustrates the difference in anti-static properties, how one of these materials just holds more static electricity than the other. What's the demo we're going to see? Explain it to us.
Basically, we're going to be trying to generate some static on the surface of these parts. We've got this big kahuna frisbee. We've been able to generate quite a bit of static on this just with this motion, and so you'll see how much powder sticks to this frisbee just from the static on this surface. And we'll repeat the same experiment with these 2 parts as well. So we have one that's printed and vapor smoothed in the white, the PA-1200, and then we have this one that's printed and smoothed in the HD 950.
Let's do it.
All right, so we're gonna make some static here by running this brush over the frisbee, put it in the white, and see how much powder sticks to that. I'm gonna give it a little bonk and see not very much of that coming off. A lot of it's still stuck to the surface there. And we'll repeat the same thing in the black, and we'll go ahead and generate some more static here. And you'll see we'll dip it in the black. Still quite a bit of powder there, but look how much of it comes off when you bang on it. So what we want to show is same experiment with these 2 parts so that you can see visually, hopefully, how much static is being generated on the surface of the black versus the white. So we'll do the white first. Again, just trying to put some static charge on the surface of these parts. Just put it in there. Oh, get a little better there. And see how much powder's falling off that, but there's still lots and lots of powder on that. We'll try the same thing on the black. You can see already less powder stuck to the surface of it, but most of it comes off.
So very similar materials, same parts, but what is the potential value of greater anti-static properties in this material?
Largely, I think electronics, electronic housings, things like that, where you kind of need an inherent statically neutral plastic, but maybe you don't need the ESD safe rating. Additionally, we noticed there's some applications on the medical side of things too, where it's still the nylon 12. It's got some biocompatibility data on it. There's uses in the pharmaceuticals industry where you're dealing with a lot of powders and mists and vapors and things like that, where you don't want that static buildup.
You discovered this effect as you began to work with this material. One other scenario in which you see this anti-static effect is just the basic routine act of vacuuming out the powder. Can we see that difference?
Sure.
All right, you mask up, I'll step back out of the way.
Okay. You can see how much powder is still stuck to this white part. I'll do the black.
And see, there's still some, but not a lot stuck to that part.
So I could see that from back where I was, that a lot more material was clinging, just static cling to the nozzle. White material, black material. You're just starting to investigate this effect. Do you have a hypothesis why it is that the darker material has the anti-static effect?
The carbon content itself could have something to do with that. Again, it's not to show that it's inherently better, or like, it's just to show the norms of what we see every day in working with the white, and just some novelty that we've noticed when working with the black.
Black PA-12 nylon, inherently black, a dye alternative to getting the black color, but then also some interesting other properties that Lifestyle Additive is discovering. Stay tuned, more to be revealed as they investigate this effect further.